Do you know what is algebraic expression, Apurva? In your previous class, have you learned algebraic expression?
Yeah, we've learned in eighth grade.
Okay, yeah. If I write that x plus y plus z, is it an algebraic expression?
Yeah,
Yeah, of course it is. Okay. If I'll write xy plus yz plus x square plus y square, is it an algebraic expression?
yeah,
Okay, so these are example of algebraic expression. Now polynomial means we will be checking whether these, okay, whether expressions are polynomial or not. Can we call these expression as a polynomial or not? So basically polynomial means we are checking that whatever we have seen algebraic expressions till now, those are polynomial or not. Okay, so polynomial is basically one expression. In mathematics, two things must be clear to us. One is equation, second is expression. Equation means there will be equality sign. LHS will be there and RHS will be there. Okay, LHS will be there and RHS will be there. Yes, okay. So LHS will be there, RHS will be there. Whenever we will see an equality sign, we are going to call that as an equation. Okay, an expression means just algebraic expression will be there, no equality sign, nothing will be there. So in between these two, okay, it's clear, right?
yes, ma'am.
Yeah, so here we are sticking with expression. Okay, polynomial means, okay, just one expression. Now there are two most important criteria which will help us identifying the polynomial. First criteria is polynomial in one variable. So this chapter is all about one variable. Okay. So here in the first algebraic expression, clearly we can see x variable is included, y variable and z variable. So three variables are included over here, right?
Yeah.
Next one we can see again x, y, z. So three variables are included over here. Okay. So we are just checking what are the different type of variables are just included over here. Just like when we are baking a cake, okay, we are using ingredients. So one of the ingredient can be flour, another ingredient can be sugar. So we are not thinking about the quantity of sugar and quantity of flour now. I am just saying two ingredient. One of them is flour, another is sugar. Similar,
Mm.
in the next example, I am saying three different variable I can see. One is x, another y, another z, right?
Mm.
Okay, this chapter is all about polynomial in one variable. So our example must look like this: x square plus x plus 5. Here we can say that only one variable is involved, that is x. Number of time, okay, one of the x is having power 2, another x is having power of 1. Okay, so whatever be the number of time we can see x over here, that doesn't matter. We will just say that only one type of variable is included. That means one variable is there. Making sense?
Yeah.
Okay, so one variable means only one type of variable has to be there. So even if I am writing y to the power 5 plus 3y to the power 7 minus 24, still we will say one variable is involved over here, that is y. So far, is it
Mm.
clear?
Yeah.
So one of the most important criteria for polynomial is there has to be one and only one variable. Okay,
Mm.
this criteria is really important. In this class we are having a chapter polynomial. In next class also, in class 10 again we will be having polynomial. In
Mm.
class 11 again we are having, okay, few here and there. Properly one chapter is not there, but here and there we will be seeing polynomial every time. Even if just polynomial is written or polynomial in one variable is written, whatever is written, we will be thinking about one variable only. Okay, even if just polynomial is there, in my mind, one variable has to be there. This is clear. Or maybe this one variable is written over here, then that is great. So
Mm.
polynomial or polynomial in one variable, both mean same. One variable has to be there. Making
Mm.
sense?
Yeah.
Okay. Now, next condition, which is also really important. It says that first check in your expression, is there only one variable included? If that is the case, then check the next condition, that power or exponent of each and every variable has to be a whole number. Power of each and every variable has to be a whole number. Okay, so let me explain it, what exactly it's trying to say. If we are having a polynomial, let's say 2y to the power 8 minus 3y to the power 7 plus 4y cube plus 24. So first thing is it algebraic expression having just one variable? Yeah, it is, right?
Yeah.
Next condition says that if the first criteria got fulfilled, then please check minutely exponent of the variables. Okay, variable, we can see this is variable, this is variable, this is variable. Just focus on the exponent of each and every variable, this exponent, and this exponent. Just focus and check one by one. Is it a whole number?
Yeah.
What is whole number?
Numbers starting from 0 to infinity.
All counting numbers starting with 0. Okay.
Yeah.
So yeah, this is also whole number 7. This
Yeah.
is also whole number.
Yeah.
So we need to check the power.
Mm.
Power of, if here I am writing 2 to the power minus 1, that we don't have to check. We
Mm.
have to check the power of the variables. If
Mm.
those are whole number, each and every power. Okay. So many times you will be able to see variable maybe. So you have to check each and every power. If all are whole number, then you will declare that yes, the given expression is polynomial.
Mm.
So far, any confusion, Apurva?
No.
Let's see a few more example. Suppose we
Okay.
are having x to the power 5 plus x to the power 6 minus x to the power negative 3 plus 4. Is it a polynomial, Apurva?
Yeah.
Let's check it. First condition says that only one type of variable has to be there. We can see
Mm.
xxx, fine.
Mm.
Condition says that power of each and every variable. This is variable, this is variable, this is variable. So power of each and every variable. This power, and this power. We will be asking question from ourselves. The first one, is it a whole number? So
Yeah.
5 is whole. Okay. So yeah.
Mm.
Next, is it whole?
Yeah.
Yeah, this is whole. Next, minus 3, is it whole?
No.
So if any one of them is not whole, then stop and declare that no, it is not polynomial.
Mm.
Getting it?
Yeah. Yeah.
Okay. So these are the only two criteria, and each and every time we'll be checking these two. Okay, both of them carefully we will be checking, because after giving example once, I will start writing that x to the power 8 plus xy to the power 5 plus 24, and I will ask, is it a polynomial? Then what you will say?
Uh, no.
Why?
Because there's two variables.
Exactly. Okay, so just we will focus on both the rule. It's
Mm,
not a polynomial. Okay, it's
mm,
not a polynomial in one variable. So, yes. Next. Now, there are few rules which will help us identifying polynomial. So, in your previous class, you have learned square root and cube root chapter, right?
Yeah.
Number system chapter also you are learning in your school. I'll be also taking it properly. Okay. But few rules are there in number system
Mm,
chapter towards the last. Okay. Rule of
okay.
exponent, which we call as a law of exponent. Few rules
Mm,
here we will be using very often. So I'm going
mm,
to tell you those rules first. So first rule is, if we are having a square root of 2, that can be written as 2 to the power 1 by 2. If we are having a square root of 5, in exponent form, we can write it as a 5 to the power 1 by 2. If we are having a square root of 7, in exponent form, we can write it as a 7 to the power 1 by 2. If we
mm,
are having root of 8, in exponent form, we can write it as a 8 to the power 1 by 3. If we are having fourth root of, just suppose, 16, we can write it as 16 to the power 1 by 4. So whatever be the root, that can be written in exponent form like this. Whether it is
mm,
a perfect square number, perfect cube number, not perfect cube number, doesn't matter. We can
mm,
write like this in exponent form. Is it making
mm.
sense?
Yes, ma'am.
If we understand this logic, then you will encounter this type of example, Apurva. That
Mm,
our example looks like we are having root x, okay, plus x to the power 5 plus 24, and again the same question will be there, that identify whether it is polynomial or not. So we will
mm.
say that root x can be written as x to the power 1 by 2, right, Apurva? Can we? Are you there?
Yes, ma'am.
Can
Got
we?
stuck.
Yeah. Okay, can we write root x as a x to the power 1 by 2?
No.
Okay, just now we were discussing this rule only, that the square root of anything can be written in exponent form like this, right?
Yeah, yeah,
Okay, this rule is clear, Apurva. It doesn't
yeah.
matter number is there or x is there or a is there or b is there, whatever is there.
Mm,
Inside the root, whatever is there, we can write it in exponent form like this. Okay,
mm, mm.
so if we understand this rule, then we can write root x as a x to the power 1 by 2, right?
Yeah.
Okay, then x to the power 5 we will write as it is, plus 24, and now we will be analyzing both the rule. The first rule says that one and only one variable has to be there. We can clearly see one variable. Okay. Next rule says that please check the power of each and every variable if those are whole numbers or not. So this 1 by 2 power, we will be checking, is it whole? Is it whole, Apurva?
No.
So here only we will make the declaration. We don't have to check ahead. We will say no, the given expression is not polynomial.
Mm,
Getting it? So whenever an algebraic expression will be given to us, okay, quickly we will not make the conclusion. We will think that if we can write it in exponent form or not. Okay,
mm,
I'll be explaining this rule in first chapter, but here also I'm explaining it, that anything inside the root, square root sign, can be written as this one in exponent form. And yeah, Apurva, I'm not telling that you should know it. You have never learned it. For the very first time, I'm telling you that this square root can be written like this. Okay.
mm,
Basically, here 2 was there, so we are writing power 1 by 2. If 3 will
yeah.
be there, then we will be writing power 1 by 3.
Mm,
Getting it?
yeah.
So this type of question will be there to confuse you. That if
Mm,
root of t plus 25 we are having, then the question is identify whether the given expression is polynomial or not. Okay, so we will be checking it like this. First rule says that one and only one variable, so we can clearly see only t is there. Great. Next rule says that power of the variable, this t, what is the exponent of this t, Apurva?
T 1 by 2. The
T,
T1, T.
t, what is the exponent of t? This is not inside the root, right?
Yeah, yeah.
Okay.
T raised to 1.
Yes. So that's why I was telling you that the question will try confusing you. That one time it will give t inside the root, another time it will give t outside the root. But we
Mm.
must be clear with the fundamental that power of the variable. Okay, if the
Mm.
variable's power is a whole number, already we can see in this example the t exponent of t is 1, which is a whole number, and we don't need to worry about this root 2. In the first example I told you 2 or 3 or this 25 can have any power, and we are not going to check that, right?
Mm.
Okay, if this t is fine for us, we will declare that yes, it is polynomial, right?
Yeah.
So far, any confusion?
No.
Okay. Now I'm going to tell you the next rule. Okay. Before that, let me give you one example that if we are having 2x plus 5, is it a polynomial, Apurva?
Yeah.
Yes, it is. Okay. Next rule I'm going to first explain you, and on the basis of the rule, we will be seeing the example. So the next rule says that again, it's from law of exponent, which is there in first chapter. I'll be explaining it over there as well. And here also, I'm explaining in detail. Okay, it's not that we are using it here, but I'm just telling you that take this rule as it is. No, I'm
Mm.
explaining you here also. I'll be explaining you there also. So, law of exponent says that anything to the power 0 is 1. Okay, anything having power 0 is nothing but just 1. The result will be 1. If you will ask me what will be the value of 2 to the power 0, I will say result is 1. If you will ask me what is the value of 3 to the power 0, I will say result will be 1. If you will ask me what is the value of 10,000 to the power 0, I will say the result will be 1. Okay, so basically we understand if we are having x square, that means x into x. If we are
Mm.
having x cube, that means x into x into x, right?
Mm. Yeah.
We are having x to the power 4, that means x into x into x into x. If we are having x to the power 1, that means just x. And if we are having x to the power 0, that means just 1. Getting
Mm.
it?
Yeah.
Okay. So anything having power 0 is 1. A plus b to the power 0, a plus b whole to the power 0, 1. Okay,
Mm.
anything, any variable, any alphabet, any number to the power 0, that means it doesn't exist. Okay,
Mm.
bare minimum power 1 has to be there, then only we will say it is x. And if the
Mm.
power is 0, that means this x is not there, right?
Yeah.
Okay, so this is a rule, again law of exponent.
Mm.
We are going to use this rule over here. Now example will be like this, that you are having just 35, just 35, just 35. And the question will be, please tell me now that is it a polynomial? So we will check both the rule. The first
Mm.
rule says that one and only one variable has to be there, and we are
Mm.
not able to make the conclusion, right?
Mm. Yeah.
Second rule says that please check the power of the variable, and still we are not able to make the conclusion.
Mm.
Okay, so we will take the help of the previous rule. Okay, in our mind we need to understand this 35 in a certain way. So for now, whatever I'm going to write something, you just tell me mathematically is it allowed or not. So can I write Apurva 35 as a 35 into 1?
Yeah.
Mathematically it is allowed. We are not
Yeah.
having any disaster change or something, right?
Mm.
Okay, This 35 can be written as 35 into 1, and this 35 into, at the place of 1, mathematically, can I write x to the power 0 for 1?
Mm. Yeah. Yeah.
Okay, maths will allow us to write it. Even if I don't want to write x to the power 0, then I can write y to the power 0, or maybe z to the power 0, whatever, anything to the power 0, right?
Yeah.
And in your then once you have started learning algebra and everything, you have learned that 2 into x means 2x, right?
Yeah.
So here this can be written as 35y to the power 0, right?
Yeah.
Okay, now instead of seeing this 35, if we will look at this 35 to the power 0, and we will ask both the rule is getting validated or not. The first rule says that one and only one variable. Yeah, we can see one variable.
Mm.
Have written this variable, but mathematically that is allowed, right?
Mm. Yeah.
Next rule says that power of this variable has to be a whole number. Is it a whole number power?
Yeah.
So from now onward, whenever anybody will ask that 35, is it a polynomial? We will say, yes, it is a polynomial.
Mm.
These, the thing which I have explained to you in this, okay, this curve part, this bracket thing, this one you don't have to mention to anybody. Okay, this is just for your mind map, that why we are calling
Mm.
35 as a polynomial. From now onward, whenever anybody will ask 24, is it a polynomial? We will say yes. Anybody
Mm.
will say just 3, is it a polynomial? We will say yes. Anyone
Mm.
-1, is it a polynomial? We will say yes. So in front of us, the person can give any number, okay, any integer, any decimal number, any number, and we'll ask, is it a polynomial? We are going to answer from now onward that yeah, it is
Mm.
it.
Yeah.
Okay, and if we are giving viva, if if teacher is asking in detail why you are calling it polynomial, then we can show our mind map. Okay,
Mm.
otherwise never ever we are going to see, just show these things anywhere, because this type of question you will encounter in MCQ question, where you don't have to give the declaration that why you are calling it polynomial. Okay,
Mm.
clear so far, Apurva?
Yes, ma'am.
Next, again, one more rule is there, and that is the last rule. Once we will discuss this rule and we will see the example, then we can start solving question from exercise. Okay, so let's see this rule and we will master this rule. So for the very first time, when I will write this rule on the screen, and if it is not making sense to you at all,
Mm.
please don't worry. Okay, we will master this rule, we will understand it. So again, a law of exponent says that x a to the power minus n can be written as 1 by a to the power n. Okay, it says that 2 to the power minus 5 can be written as 1 by 2 to the power 5. Now I'm coming to the explanation part. This rule is trying to tell us that mathematically, if you are having a number which is sitting in the numerator, and if you want to shift it in the denominator, then maths will allow you, from now onward, maths will allow you to do so. You can take the number as it is and you can drop it in the denominator. Only one
Mm.
change you have to do, just one change. If your power was negative previously, this time your power will be positive. Okay, the number's exponent. Okay, if already it was positive, then this time it will be negative. So you just have to reverse the sign of the power. When you
Mm.
are switching the place of any number from numerator to denominator, or from denominator to numerator, from now onward, maths will allow you to do so. Okay.
Mm.
You just have to, if you are having, suppose 3 by 8 cube, and you want to, this 8 is telling me I want to go in the numerator, then I will say that yeah, maths will allow you. Okay, I can write 8 cube in the numerator beside this 3 in multiplication. In denominator, 1 will be there. But at the same time, I have to reverse the sign of the exponent. If it was positive, I have to make it negative. If it
Mm.
is negative over there, then I have to make it positive now. Making sense?
Yeah.
Okay, we will master this rule. Let's see few more example. If we are having 2 to the power 8 by 3 to the power minus 2, this 3 is telling me that I want to go in the numerator, and 2 is telling me I want to go in the denominator. Now I will say that yeah, it is allowed now. Okay, 3 can be written in the numerator, but I will reverse the powers. Okay, the power sign only I will reverse. If it was negative, now it is positive. And 2 to the power 8 can come in the denominator. I just
Mm.
have to reverse the sign. Got it?
Yeah.
If already a number would be there in the denominator, then 2 will come beside that in multiplication. Okay, 5
Mm.
will say that don't worry, you can sit there. Okay, and 2 to the power minus 8 can sit here like this. Got it?
Mm. Yeah.
So if we are having 1 by 2, can I write it as a 2 to the power minus 1? 1 into 2 to the power minus 1? Yes or no?
Yeah.
That means just 2 to the power minus 1, because 1 multiplied with anything is just same thing. Right, Apurva?
Yeah.
Okay. Or maybe if we are having 1 by x square, and this x square is telling me I want to go in the numerator, so we can write x to the power minus 2 here. Right? 1 multiplied with that, but 1 multiplied is the same thing. Right?
Yeah.
Got it.
Yeah.
Let's use this rule. So suppose we are having 1 by x plus x to the power 5 minus 2x to the power 4 plus 20. And we have to check whether it is polynomial or not. But now I want to add one more thing over here. For checking whether it is polynomial or not, you should keep all the variable in the numerator. Then only you can compare the powers. Okay, each and every power are whole number or not. Making sense?
Yeah.
Okay, so we will not keep this x in the denominator. That one of the x is sitting in the denominator, another x is sitting in the numerator, and we are just keep on checking the power. No, we will make sure that all the variable are there in the numerator, all the variable. So the
Mm.
x, we will bring it in the numerator part. Okay, so what are we going to get, Apurva?
1 into x minus 1 raised to minus.
Okay, which can be written as x to the power minus 1 as well. The remaining all the term will be as it is, right?
Yeah.
Now we will check both the rule is getting validated or not. So one variable has to be there. Great, it's there. Power of each and every variable has to be a whole number. And can we see this minus 1? It is not a whole number.
Mm.
This is not a polynomial.
Yeah.
Okay. Now, when I have shown this example, then few students started writing that since x is sitting in the denominator, that's why this is not a polynomial, but that is not true. Okay, if
Mm.
suppose I am giving you another example, Apurva, that 1 by x to the power minus 2 plus 32 x to the power 4 plus 5. And again, I am telling you, is it a polynomial or not? So our job is to bring all the variable in numerator, right?
Yeah.
So we will be bringing it in the numerator. What are we going to get?
X raised to 2 plus 32 plus 5.
So just because that x was there in the denominator, that doesn't mean it is not a polynomial, right?
Mm. Yeah.
Okay, we will still, we are having just
Mm.
two rule. In each and every circumstances, we'll be checking these two rules only. So here again,
Mm.
we are checking these two rule and both are getting validated, right?
Yeah.
Clear so far?
Yes, ma'am.
Now I'll be showing you a question which is there in your NCRT. Today only after the class, if you will open NCRT, at least this much you are done. So let's see. Question number one, we will focus on this. Okay.
Mm.
Let's read the instruction. Which
Mm.
of the following expression is it readable, Apurva? Is it readable?
Yeah, yeah.
Okay, expression are polynomial in one variable, so we have to identify which one is polynomial in one variable, which is not. Okay, so the
Mm.
first one here, is it a polynomial, Apurva?
Yes.
Yeah. Next one, is it a polynomial?
Yeah.
Yeah, because root 2 is not going to confuse us. Next
Yeah.
one, is it a polynomial?
Yeah.
Okay, let's take a pause. This root t can be written as t to the power 1 by 2,
1/3.
1 by 2, because this 3 is multiplied. Okay, there are two type of
Oh.
cases. One is teeny tiny 3 if I'll write like this. Then this will be t to the power 1 by 3. And if I'll write
Oh.
bigger 3, a bigger 3, a huge 3,
Mm.
like this. And then root t, that means square root is there. And 3 is multiplied with that, right?
Mhm. Yeah.
Okay, so here actually we are having a square root. That means t to the power 1 by 2, we are having 3 is sitting in front, right?
Yeah. Yeah.
And due to this reason, we can see the power of the variable that is not a whole number, right?
Yeah.
So it's not a polynomial, right?
Yeah.
Next one. If we are having fourth one, is it a polynomial, Apurva?
No.
No. Okay, 2 by y you will bring in the numerator. It will be 2 into y to the power minus 1. Okay.
Yeah.
One. Next 5. Is it a polynomial?
Um. No.
No. So many variables you can see over here, right?
Yeah.
So far, any confusion?
No.
One more concept I'll give you. Okay.
Mm.
Do you know what is coefficient?
The variable selector.
If I am writing 2x square plus 5 and I am asking what is the coefficient of x square? Coefficient, that means multiplier of x square. What is
Mm.
multiplied with x square?
Mm. 2.
Okay, and we will say coefficient of x square is positive 2. Making sense?
Yeah.
Okay, so in your notebook you can just coefficient of x square, just a moment, x square is equals to positive 2. We will be specific with the sign. If here you can see minus 2, then you will be writing minus 2. Making
Mm.
sense?
Yes.
Okay, so this is how we need to find the coefficient in each and every example for the second part. But, okay, we also, suppose I am writing one more thing. Suppose I am writing x square minus x plus 5. And if I'll ask you, Apurva, what is the coefficient of x over here? Can you tell me?
No. There's.
Can we say minus 1?
Yeah. Yeah.
Okay, minus 1 is multiplied with x. If suppose
Yeah.
x is there, then we will say plus 1, right?
Mm.
If plus x is there and I'm asking what is coefficient of x,
Mm.
so we will write plus 1. If you can't
Yeah.
see anything, coefficient is 1.
Mm.
Okay. You just have to be specific with the sign plus 1 or minus 1. So you're
Mm.
not getting confused, right?
Yeah.
Okay. Now in this question, I can also ask you, Apurva, that what is coefficient of x cube? Can you see any x cube over here? No, right? Here. No.
No.
Coefficient will be 0.
Mm.
Okay, so question will try confusing you that what is
Oh.
coefficient of x to the power 4, x to the power 5. So we will say there is no x to the power 3 and all. Okay,
Mm.
even if we are thinking, we can think in this manner that 0 into x cube in our imagination is sitting over here maybe. Making sense?
Yeah.
Okay, so if you understand this much, then we can answer question number 2 now. Let's read the instruction. It says that write the coefficient of x square in each of the following. So for the
Mm.
first one, what is the coefficient of x square, Apurva?
1.
Plus 1.
Yeah.
Yeah, right? You can
Yeah.
write just 1. Okay, I'm just giving the impact on plus 1 because in next part you have to mention the sign, right?
Mm. Yeah.
What is the coefficient of x square, Apurva?
-1.
What is the coefficient of x square in the next one, Apurva?
+1.
Next, third one.
Mm. The
Pi is
count.
just a number. Number
Uh,
system you are learning. So there you have learned that pi is just a value, a decimal number.
yeah.
Okay, and previously you were using pi as a 22 by 7.